So continuing on with atomic theory, we'll move from that to periodic table, kind of the order that we get started. So there's 3 laws that govern how matter behaves. The first one is called the law of conservation of mass. And it states that matter is neither created nor destroyed during a chemical reaction or physical changes. So this is the reason we balance equations. I'm going to put EQ for equations. If you've done it correctly, you should be able to balance it so you have the same number of atoms on each side, because that shouldn't change. What they're combined with or not combined with will change probably, but not the actual number. The other one is the law of definite proportions. And that states that a chemical compound contains the same element in exactly the same proportion by mass, regardless of the size of the sample or the source of it. So sodium chloride is table salt. So no matter where I get that sample from, it's always going to be 39% sodium and about 61% chlorine. If you look at the formula, I only have 1 atom of each, but the chlorine is a much heavier atom. So that's why it takes up a larger percent mass. And the last one is the law of multiple proportions, which is a lot of words that kind of state something actually pretty easy. It states that if 2 or more compounds are composed of the same 2 elements, then the ratio of the masses of the second element combined with a certain mass of the first element is always a ratio of small numbers. And those small numbers are your subscript. If you remember probably from middle school somewhere, H2O, that little 2, that's what we're talking about. We're talking about a subscript. It's within a formula. So that's a lot of words, but basically it's saying if I take 2 elements, so let's say that I'm going to take copper and I'm going to take carbon and oxygen. If I combine 1 atom of each, I get carbon monoxide. That's pretty dangerous. If I change it up and now have 1 atom of carbon, but 2 atoms of oxygen, it changes it to carbon dioxide. So same 2 elements, but just changing up how they're combined completely changes the compound. All right. So John Dalton, he came up with the Dalton's atomic theory, if you remember from the last couple of days. And this was back early 1900s, and it had 5 parts or 5 postulates. The first one is all matter is composed of extremely small particles called atoms. Yeah, eventually it wasn't originally that word, right? But he did continue to use the word that was used earlier. Atoms of the same element are exactly the same in size, mass, and other property. Atoms of different elements are going to differ in those same things. Atoms cannot be subdivided, created, or destroyed. Number 4, atoms of different elements combine in simple whole number ratios. So once again, that's the subscripts. I can't combine half an atom of hydrogen. It's always going to be a whole number. And in chemical reactions, atoms are combined, separated, or rearranged. So of those 5 parts that were all the way back in early 1900s, most of them have stayed true. Postulate or part number 2 and number 3 have had some changes or some things that were later discovered. So number 2 is the one that said atoms of the same element are exactly the same. And now we know that's, I should have said number 2 on that. So isotopes, and we'll talk more about those tomorrow. Later on, isotopes were discovered, so they found that sometimes there could be some small differences. And then for number 3, which is the one that said that atoms cannot be subdivided, later on, then all the subatomic electron, proton, neutron, subatomic particles were discovered, which means that although it's very hard, atoms can be broken down into some other things. Right, structure of the atom. So we know good old Democritus, a long time ago, 400 BC, came up with the idea that matter was composed of tiny particles called atomos. And we continue to use that, just change it up a little bit. His teacher, Aristotle, disagreed. But people believed Aristotle instead of Democritus because he was a teacher, but really it was Democritus who was correct. J.J. Thomas discovered the electron. Negative, because electrons are negative. He used something called the cathode ray tube. The electron was discovered first because it was charged and small. That's why it was the one that was easiest to discover. If something is charged, then you're able to manipulate it some, and then with it being so small. The next 2 blanks, and that's going to be it. Plum pudding model that would have been your chocolate chip cookie yesterday helped to protect the protons. Also charged. So at this point, scientists knew that the atom is neutral. So if they discovered the electron, they had to figure out what was offsetting that charge. So they went on to discover the proton. And then Rutherford, he discovered the fact that the nucleus is where the mass of the atom exists. He used what's called gold foil experiments. And then I know there were some questions on that assignment last night that maybe talked about Chadwick. We hadn't gone over them, but I just gave everybody a +10 is how I handle that. So he discovered the good old neutron. It didn't have a charge, so that's why it was the hardest one to discover. So they just realized there was still some mass missing. And so that is why it was discovered. All right, that looks like a good place to stop for today. And the video that's been in there for a few days, try to watch that. It just does some background.